Okay, new unit, and you might find this one quite a bit different with composition of functions. There wasn't much we can do visually. It's much more abstract. Getting back into exponential growth and exponential decay, it's more visual. We're able to do some graphing, and the examples are more concrete and less abstract. So our growth and decay functions. The interesting thing about them is that the x is actually the exponent. Right, so the number we're going to plug in, we're going to be plugging into the exponent. If you're wondering why a cannot be 0, well, if a is 0, it's just a constant function, y equals 0. Base cannot be the number 1, because if the base is 1, we basically just have a times 1, which is a, and then we got another constant function. We'll get growth if a is positive and b is greater than 1. In that case, b is called the growth factor. Simplest of the bunch, if a equals 1, 1 times b to the x power is just b to the x power, and we just get this form, y equals b to the x. This is what our basic function looks like. And in a moment, we're going to get a hands-on opportunity in class. If you're trying to watch this at home, this is probably not going to have the impact that we have in class, because in class we're going to do a little bit of hands-on work here. So if you're redoing this at home, you're almost better just going through the PowerPoint than trying to listen to the video on this one. Now, if b is positive but less than 1, then we get decay instead of growth. We still get a hug our asymptote, and we still find ourselves going through 0, 1. So in class, we're actually taking a break from the PowerPoint right now, and I've got a little hands-on activity we're going to be doing. And then after that, we'll be resuming the lovely PowerPoint in progress. So if you're in class, we kind of talked about how I could change the base, and sure enough, we're still going through that point 0, 1. Sure enough, the x-axis is still asymptote. Sure enough, we still go toward positive infinity as we go off to the right. And in class, again, if we have a positive base but it's less than 1, we now have decay. We still go through the point 0, 1. We still have the x-axis as an asymptote. But instead of going up to positive infinity as we head to the right, instead we go up to positive infinity here as we head to the left. But since we normally read a graph from left to right, we're actually falling from positive infinity. And then as we head to the right, we approach the x-axis as our asymptote. Of course, in class, we'll be working with IXL, and we'll be asking, hey, what happens if instead of just 2 to the x, what if we introduce that factor of a, that coefficient a? Discover the general shape hasn't changed. We still hug the asymptote. And then as we head off to the right, we go up toward positive infinity. Big difference. Instead of going through 0, 1, we find ourselves going through 0, a. If a is 3, we go through 0, 3. If a is 7, we go through 0, 7. You probably remember what that plus 4 is going to do. You probably remember what that minus 3 is going to do. Plus 4 lifts the whole graph up 4 units. That minus 3 drops the graph down 3 units. Of course, a negative is going to flip the graph upside down. So notice on the red one, it's flipped upside down. We're hugging the asymptote. But then instead of going up to infinity, we go down to negative infinity. The blue one, g of x, lifts it up 2 units. So instead of going through 0, 6, it goes through 0, 8. Asymptote, instead of being the x-axis, is the line y equals 2. The green one, notice the asymptote is now up to 3. And the negative flipped it over. And we got some IXL. Again, this was probably much more meaningful in class, not too useful as something on YouTube to watch. So my suggestion would be, instead of watching this on YouTube, that you actually just download the PowerPoint if you need to review some slides.